So hello learners, welcome to the IITM student community channel. Today we will be solving the week 3 graded assignment questions in this session. So now let's begin. Okay, so today we are going to solve the numerical answer type questions, in which question number 1 has written that consider the set of 3 vectors s is equals to c minus 1 minus 2, 1 0 and minus 1, minus 1 minus 3 and c in R cube with usual addition and scalar multiplication, for which the value of c will the above set S be linearly dependent. So now let's find the answer. So at first we'll write the 3 sets in this form, that is c minus 1 and minus 2, 1, 0 and minus 1, minus 1, minus 3 and minus c. Now we'll write it as the process of cross multiplication. Hope you all know well that how do we use the method of cross multiplication for these type of questions. So c into minus 3 minus 1 into minus c minus 6 minus 1 into 1. So now we have minus 3c plus c plus 6 minus 1. After solving this, we'll get minus 2c plus 5. And then as written in the question, the vectors are linearly dependent if there will be the given equation is equals to 0. So minus 2c plus 5 is equals to 0, then minus 2c is equals to minus 5 if we put 5 on the other side. Then 2c is equals to 5 upon 2. By solving this, we'll get to know that c is equals to 2.5. I'm sorry, in the third line, it's written that 2c is equals to 5 by 2, but it's actually c is equals to 5 by 2. Here's question number 2, that is find the value of c for which the vector minus 226c will be in the spanning set of two vectors that are 1 0 1 and 0 1 minus 1 in R with usual addition and scalar multiplication. So here's the answer written that minus 2, 26 and c will be in the spanning set of two vectors that are 1 0 1 and 0 1 minus 1 in R cube if and only if these three vectors are linearly dependent, as written in the question. So now we'll write the set as written in the table, that is 1 0 1, 0 1 minus 1, minus 2, 26 and c. All these are equals to 0 because it's written that these vectors are linearly dependent. So as we did in the last question, that is the first one, we'll solve it as a cross multiplication. So again it's 1 into c plus 26 plus 1 into 2, that is equals to 0. So by solving this, we'll find that c plus 26 plus 2 is equals to 0. And by solving this, we'll reach to the conclusion that c is equals to minus 28. So here we got the answer, that is c is equals to minus 28. Up next, we have our question number 3, that is written that consider the subspace V is equals to xyz, z is equals to 7x plus 6y, where xyz belongs to R of RQ, and span P010Q1 is equals to V. Find the value of 1 by PQ. It's written that 1 and space with PQ, but the actual question is 1 upon PQ. We have to find the value of 1 upon PQ. So here's the solution, that is P0 and 1 belongs to V. Please remember that it is the sign of belongs to, and 1 is equals to 7p, 1 upon p is equals to 7. Similarly, 0q in 1 belongs to V, that 1 is equals to 6q, 1 upon q is equals to 6. Then by multiplying these terms, 1 upon q into 1 upon p is equals to 7 into 6. So 1 upon p into 1 upon q is equals to 1 upon pq, that is equals to 7 into 6 is equals to 42. So now we have our question number 4, that is, consider the set of 3 vectors s is equals to 7, 7, 2, 8, 7, 4, 5, 7, c in Rq with usual addition and scalar multiplication. If S is a linearly dependent set, then the value of c that cannot be equal to what? So now let's find the answers. Okay, so here if S is a linearly dependent set, then we know that the given set will equals to 0. So 7, 8, 5, 7, 7, 7 and 2, 4, c, that is equals to 0. As I'm writing here in the table, that is 7, 7, 2, 8, 7, 4 and 5, 7, c is equals to 0. And after that, we'll solve this given set by the process of cross multiplication. Then we have 7 into 7c minus 28, then minus 7 into 8c minus 20 plus 2 into 56 minus 35 is equals to 0. As I am writing here, equals to 0. Yeah. And next line we have 49c minus 196 minus 56c plus 140 plus 42 is equals to 0. Then we have minus 7c minus 196 plus 182 is equals to 0. Then minus 7c minus 14 is equals to 0. So by changing the sign, we have 7c plus 14 is equals to 0. Then we have 7c is equals to minus 14. If we change the side of 14, then c will equals to 14 upon 7. That is minus 14 upon 7. Then we have c is equals to minus 2. And hence if S is linearly dependent set, then the value of c can't be minus 2. Okay, I'm sorry, it's linearly independent set, then the value of c can't be minus 2. So students, for more updates and more questions like this, please join our channel.